Hello, and welcome to the State of Serverless. My name is Jeremy, and I'm the Director of Technical Community and Open Source here at Datadog. If you have any questions or comments, want to make a correction, or just talk about serverless, observability, open source, or anything else, hit me up at Linux Questions on Twitter, and I'm always happy to have those discussions. For those of you unfamiliar with Datadog, it's an observability platform that provides full visibility across your entire organization. We have everything from infrastructure metrics, distributed tracing, and APM and logs, all under a single pane of glass. We've recently added things like security monitoring, compliance monitoring, synthetics, RUM, and much, much more. So if you're interested in learning more about that, go to datadoghq.com. But what's important for this particular talk and this report is that more and more of our customers are using serverless, and this gives us a wide amount of information to create a report of this nature. Let's start with some definitions, and I'm not going to try to define serverless here. I understand that it has quite a few different definitions and depends on who you're talking to and what portion of the ecosystem you're talking about, but I would like to set some context for its usage in this particular talk. So what we're going to focus on here is a subset of serverless known as functions as a service, which is well defined and well understood so that we're all on the same page. For the purposes of this talk, we're going to focus specifically on AWS Lambda, which at the start of 2020, when the data for this report was collected, it was the most mature and widely adopted serverless platform, certainly function as a service platform in our user base and realistically and beyond our user base. Now, in future editions of this report, we will examine and include serverless offerings from other providers such as GCP and Microsoft Azure, but again, to be clear here, this is just AWS Lambda usage. Let's talk a little bit about the methodology used for these numbers, because obviously that's important whenever you're looking at data of this nature. Let's start with population. We compiled usage data from thousands of customers in Datadog's customer base. But while Datadog customers cover the spectrum of company size and industry in a wide variety of demographics all the way around, they do share some common traits, and I'll underscore those here. First, they tend to be serious about software infrastructure and application performance, which is probably unsurprising given the nature of what we do as a company. They also skew towards adoption of cloud platforms and services more than the general population. So all of the results in this report are biased by the fact that this data is coming from our customer base, which is a very large but imperfect sample of the entire global market. Let's move on to Lambda adoption. We consider a company, for the purposes of this report, to have quote-unquote adopted Lambda if they ran at least 5 distinct Lambda functions in any given month. Now, the Datadog forwarder is a Lambda function, and that is explicitly excluded, so that, again, that's 5 distinct Lambda functions that are not the Datadog forwarder. Let's move on to AWS usage. We consider a company to be, quote unquote, using AWS for this report if they ran at least 5 distinct Lambda functions or 5 distinct EC2 instances in any given month. Now, the reason that we do this is it allows us to capture an AWS user base comprising companies that are exclusively running EC2, companies that are exclusively running serverless, or companies that are running a mix of both. Scale of environments. To estimate the relative scale of a company's infrastructure, we examine the company's usage of serverless, of containers, of physical servers, of cloud instances, and a variety of other infrastructure services offered by Amazon. So the boundaries between these categories, which for this report are small, medium, large, and enterprise, they're necessarily artificial, but I can say the trends across these categories were very, very clear. So do keep these definitions and this methodology in mind as we go through these numbers and through this data and through these charts together. All right, first up is adoption. Just shy of half of Datadog customers that use AWS, and now remember our methodology here, have now adopted Lambda. This is up from about 20% in January of 2018. So what we're seeing here is a very steady climb. You will notice probably the two little bumps there, and there's no way for us to definitively confirm here, but this is likely due to the timing of reInvent, which is usually late November, early December. What does this mean to us? Lambda is clearly no longer a niche technology, and it's realistically no longer limited to cloud native early adopters or niche use cases. On the contrary, we're seeing serverless functions are now in widespread use across a variety of companies within infrastructure and AWS. Not only that, but Lambda is more prevalent in large environments. And this one was, to be frank, a little bit of a surprise to me. The widespread adoption of Lambda has not been driven by newer, smaller companies. Rather, what we're seeing is a clear correlation between Lambda adoption and the scale of a company's environment. So whether that environment is primarily servers, primarily containers, primarily serverless, or a mix, it doesn't matter. In fact, what we're seeing is among the companies with the largest infrastructure footprint, which is all the way to the right and labeled enterprise here, more than 3/4 have adopted Lambda, while for the smallest, it's closer to 1/3. So a pretty stark difference. Now, many, and as I indicated, me included, expected smaller you perceive them to be more nimble companies to be the early adopters here and larger enterprises to be the laggards, but the numbers just do not bear that out. It is not the case. And we're continuing since this report to see the trend of significant Lambda adoption in the largest organizations accelerate even more. And a new thing that we're seeing more and more of is customer-facing serverless applications. And one thing we see quite a bit is Lambda usage will start with a security team within an organization and then grow out to other teams from there. Another thing we're seeing more and more of as this report is released is an increase in serverless first startups. Moving on a bit, container users have absolutely flocked to Lambda. And at the time of this report, which as I said was early 2020, almost 80% of organizations in AWS that are running containers have also adopted Lambda. Now, obviously, serverless functions and containers are two very different things. They're very different environments that have very different constraints, but they do tend to be adopted, we're finding, for similar reasons. The main one being abstracting away that infrastructure concern for ease of operations. They both do that, and it's clear once you adopt one, you have a very high probability of adopting the other. What we're seeing here, Amazon SQS and DynamoDB pair very well with Lambda, and really this entire slide is about natural fits. So Lambda functions calling other Lambda functions is considered an anti-pattern, a few edge use cases aside. But Lambda users have a wide variety of technology choices when it comes to connecting their functions to their infrastructure or connecting their functions to their application components. The reality here is AWS has a lot of services. So once a function's triggered, it usually sends data, or at least often sends data, to a message queue, which then routes that data onward. Message queues help organizations embrace that pay what you want or pay for only what you use model of serverless. So once again, as I said, this slide is all about natural fits. So among the services that are called or queried in the same request as a Lambda function, DynamoDB comes out on top. Again, its auto-scaling nature and low latency make it a natural fit. The next most popular choices for data stores when we're considering Lambda here are SQL databases, and that's whether we're talking RDS or we're talking self-managed, and then S3 in that order. SQS is the top choice for message queues, followed by Kinesis and SNS once again, respectively. Now, one thing we have seen post releasing this report is AppSync usage among serverless customers is accelerating rapidly. What are the most popular languages by distinct function? Well, amongst languages and frameworks, we see two clear leaders in terms of usage, and that's Python and JavaScript, really by a Node.js here. So 47% of all deployed Lambdas currently run Python, and I'll note that's my language of choice when I'm using serverless myself, and another 39% are running Node.js applications. So as you can see, this is the vast majority. In fact, the remaining 14% is split among Java and Go, Ruby, .NET, and all the other languages combined. One additional data point here on Python is that Python 3 outweighs Python 2, which, remember, this Python 2 reached end of life in January of 2020 by a factor of roughly 2 to 1. I would have thought it was a little higher than that given the end of life, but one thing that's become clear based on this and another data point that I'll get to shortly is that there are quite a few Lambdas out there that haven't been touched in quite some time. Moving on to duration. The median Lambda runs for just under 800 milliseconds, and this is averaged across all of its invocations. One thing that you'll notice here is that the tail of this latency distribution is really long. Digging in a little bit further, we'll find that nearly 1/5 of functions execute within 100 milliseconds, and then roughly 1/3 execute within 400 milliseconds. But 1/4 have an average execution time of more than 3 seconds, and a full 12% take 10 seconds or more. Now, this long duration is notable and frankly a little surprising for two reasons. And that is because serverless latency obviously not only impacts performance, that one's obvious, but it also directly impacts your costs here. Remember, Lambda pricing is based on gigabyte seconds of compute time, which is the memory allocated to the function, multiplied by the duration of its invocations. So like I said, direct impact. This also segues nicely with half of Lambdas have a minimum memory allocated. So because of the aforementioned billing model, companies running Lambda are incentivized to limit the memory allocation for their functions. So keep in mind, this is a configurable knob. This is a setting, and it's therefore much easier to control than a function's duration. Again, digging into the numbers a little bit, we find that 47% of functions are configured to run with a minimum memory setting of 128 megabytes. Now, by contrast, only 14% of functions have an allocation greater than 512 megs, even though you can allocate up to 3 gigs, which we very rarely see. Defined timeouts. Here, 2/3 of defined timeouts are under 1 minute. So each Lambda, again, has a configurable timeout setting ranging from a second to 15 minutes. The default, for some context there, is 3 seconds. So most functions, as is clear by this graph, make use of a short timeout. In fact, 2/3 of configured timeouts are 60 seconds or less, and almost half are under 30 seconds. There's 2 reasons for that. First, as I said, the default is 3 seconds, far under the 30-second threshold. But something else to keep in mind, using API Gateway to provide a REST interface in front of a Lambda is a super common pattern that we see. Because it itself has a maximum timeout of 29 seconds, any function behind an API Gateway that takes longer than 29 seconds to respond, it will result in an error regardless if the Lambda eventually completes. So that's another reason you're going to see under 30 seconds here. You might be wondering, what are the two, in the middle there's a bump, and then at the very end there's a bump. What are those on the graphs? Well, it turns out many functions have just been configured and dialed up to use the maximum allowable setting. And that's both the current 900-second setting, which is the one all the way to the right, and then the previous limit of 300 seconds. You'll notice that one's actually bigger than the one on the right. This went into effect in October of 2018. So again, we're seeing quite a few Lambdas that haven't been touched in a while. Lastly, only 4% of functions have a defined concurrency limit. Now, by default, Lambda customers are limited to 1,000 concurrent executions across any given region for all functions. From there, you can set per function concurrency limits, which effectively reserve a portion of the total concurrency for that function. And if the function then exceeds that limit, it will be throttled. Today, what we're seeing is only 4.2 of all functions have a configured limit, even though most organizations are definitely aware of that optional limit. How do we know they're aware of it? Well, 88.6% of companies do make use of concurrency limits for at least a single function in their environment. Moving on to what repercussion that have, functions that do have a defined concurrency limit are far more likely to be throttled. We took a 5-day evaluation window and found that 8.3% of functions with the limit were throttled at least once, compared to less than 1/3% of functions where the only constraint was that per region limit. I should note here, we don't have any data to share right now on provision concurrency, but it's something that we do think is interesting and something we will try to include in an update of this report. That's digging into the data, and those are the charts and information that we have. I wanted to give just a couple quotes that came up while we were chatting with serverless customers. And this one is, single engineers are now shipping projects on the order of 1 to 2 weeks that previously took multiple people much longer. And I thought this one resonated. I thought it's kind of illustrative of the operational benefits and increased efficiencies that we're seeing many of our customers gain by using serverless. Another one that I found a little bit amusing and thought I would include here is, we no longer have, quote, ops people. And this wasn't them saying that they were moving to the DevOps model. It was, kind of a joke that they had gone all in on serverless and they got automatically scalable and high availability and all those things without any dedicated team. So once again, thought this was a little bit interesting. I would be remiss if I didn't mention a couple of the common pain points that we're seeing with serverless, which, like I said, of course, do exist. So one thing that comes up a lot is there are a lot of options for building APIs in serverless. I mentioned API gateway, but some people feel like it's a little bit cost prohibitive. There's HTTP APIs, which are definitely less money, but are less feature rich. There's AppSync, which we're seeing an uptick of. There's just a lot of options, which add some additional complexity in the actual thought process of deciding. And that's the same, CI/CD comes up a lot as well. And again, it's the abundance of options here that can be a little bit tricky and a little bit of a hurdle for adoption. What we're seeing is many folks will have a CI/CD that kicks off when changes are merged into their main branch. But in that process, we see a lot of trial, a lot of errors, and a little bit of frustration. Another thing that we're seeing is stack shift. And what that is most Lambdas are deployed in a CloudFormation stack. So let's say you deploy a Lambda in CloudFormation with 1 gig of memory assigned. But at some point, someone, not being you, goes into the AWS console and changes it, let's say, to a lower setting. Now you're in a state where what you've described in your infrastructure as code isn't consistent with what's running, and now your YAML doesn't match reality, and we have seen this more and more. So with that, I'd like to open it up for questions. Once again, my name is Jeremy, and I'm the Director of Technical Community and Open Source here at Datadog. And if you have any questions, as I said, at Linux Questions on Twitter. Looking forward to your questions.